Hello everybody, this is Charles Anderson, and I am continuing on today with my Java Basics for JMonkey Engine, Part 5, Flow Control in Java 3. Yes, we have those little things called break, continue, and return, which will be covered in classes, and then of course there's the throw, which is part of the try, catch, finally statement for error catching. So right now, we're going to say the prerequisites will be flow control 2. You'll have to have and flow control 1 for this to fully make sense, because there's a project that we continue on, and because of the way that break and continue are handled, I need to make a statement for people coming in from C, C++, and assembly. There is no go-to statement in Java. It's a high-level language. That's why there is break and continue, and they only have a specific scope. That being said, in in the Java bytecodes, they're all go-tos, but that's advanced, okay? So, ready? All right, let's hit it. So, you have these switch statements, and you can have a switch statement inside of a switch statement. And you can have a switch inside of a loop. You can have a loop inside of a switch. You can have these various things inside of each other. And break, the break keyword is used with labels for nested, if then else flow control. The unlabeled form, which is the one that I introduced last lesson, is naturally set to the innermost switch statement. So whatever switch statement that you have, when you call the break thing, it's meant for that innermost one. It can be used with loops to skip past evaluation. So if you call break in a loop, it will go to the evaluation like the loop thing, but like the continue statement. However, it skips the evaluation, goes to the end of the loop, and goes on past. That's how I mentally see it. And now, continue is used with labels for a nested while, do while, and the for statement loops for flow control. The unlabeled form naturally set to the innermost loop. And these two right here are best controlled with just pop down an if then else statement, because these can lead to some oddities, which I have absolutely had fun making the code, and I've had the code for quite a while. I'm finally gotten around to doing this latest lesson, and hopefully I'll be able to go full speed with my tutorial series. So let's see. You know what? I am going to go on ahead and break into code now. That sounds great. And I have this code, and I will go on ahead and read it out. I won't type it because it took me a while to get it up there, and of course we're taking that pretty much what was in the last lesson, and got the scanner still imported, and of course there's our public class, and here's the start of our program, and declare a counting number. There's the scanner, okay. And then, of course, I count from 1 up to a number. There we are. Scanner. Okay. Still the same. Now, here, I have introduced a guardian. And this is to prevent the code from going on forever, because this code could potentially go forever and be the most annoying, worthless counter ever. But this keeps it as a functioning counter. Go figure. Then, let's see. There's string, 1 character. Okay. So... now here, this is a label, okay, and it can only go in front of a loop, which is right here. This is the start of a loop. It can only go at the start of an if statement. Here's another loop. Here's another if statement. It can also go at the front of a break, and this right here. I'll keep going. Okay, so that's the label. Now, of course, we have the printing, and I've changed up the lingo a little bit, because right here, when it hits the number 22, this code right here, this is where the problem starts, which which we've got. Oh, and I also have labels. Okay, so B label there, break and continue. Okay. Now, once it hits this at 22, it starts spoof counting. Okay, here's K. This is not actual control of the loop. It'll count 2 fake numbers. Okay, and so it'll print a fake number. Yep, spoof counter. And then, of course, we have another label for you to play with and have fun with. And here's our guardian check. Okay, here's where our program actually forgets where it was counting at. Okay, so it will actually have to start over from the beginning and start counting again. To have a statement like this as part of a loop, it will, that's just going to make it go forever. And of course, we acknowledge it in code. Yep. And here's where we increment our guardian to make sure that this here never happens again. Boom. There we are. Now here is where you'll get to play. Okay. And so you can go with if you click on this statement, of course, this is a labeled break here. And of course, it breaks at whatever label that you specify. And it can work for all the labels. Now, if on a continue statement, it works, because that's a loop. Now, if I were to say an if statement, I can break to an if statement or a switch statement, because a switch statement is like a modified break. A switch statement is a modified if then else statement. So, all right. Now we have. So yeah, you can see it'll come to here when it breaks, and it notes where it goes. If I try to do it with continue, however, it will not work because that's not a loop label. So there we are. Let's see. So I'm going to just go ahead and break. I'll just have it continue naturally, like it's supposed to. So, whoop. And here, to show you the difference between the continues and the breaks, I have where it'll output 3 periods, but see, there's a label here, and there's a label here, and you'll notice there's 2 dots. The output for a continue on this will most likely skip. Yeah, skip those 2. And a break on D label will print those. So I've just included this so that you can play with this statement right here and have fun with the program. So I also have some more text printing out here to match up for after this 4 label, or this 4, so that's C label. All right, and then of course the B label. Oh, I also specified that D label is workable with break, C label is workable with continue or break, and it's the default if you don't label. B labels for break, and so on and so forth. And then of course, once we exit out of the loop, we'll know that we've gotten up to the number, and so then all we have to do is just print out the counting number. So because I does not exist after we exit this loop. And so bada boom, bada bing, we'll have our counting number, and then I go into some other stuff, but I did not really go into this very much. Yes, I did not change this one because this one right here did an excellent job. However, you can nest some switches and have fun playing with that, and break will be the only thing that you can use. So let's see. Oh, and of course, finally, I have a little poem right here. All this has to do with try dividing. Okay, I have windows, and so I'll go into that after I show you the code. All right, let's run this thing. Let's run this thing. Okay, so I know that the magic number I mean, it'll run just fine as long as you don't hit 22. So you can go all the way up to 21. You know, and 1, 2, 3, 4. There it goes. And yes, you did fine. Yes, you're good. So let's see. Next up. Oh, you know what? Did I even code that? Rating number equals 7. Yeah, rating number. I'll wait. I guess I could try it. Anyway, so that was with the. Okay, we need to hit the magic number. I'm. That's part of the beauty of shooting from the hip is I do allow myself to get distracted sometimes. All right, so let's hit 23. That's over 22. Oop. Or well, let's hit 22. Okay, and goes 21. Oh right, 22. Now it functions perfectly. If I is greater than or equal to 22. And it actually goes in here, but yeah. Oh, right. Because it doesn't actually evaluate for 22 on that. Okay, yes. Oh, right. I've got to enter something. Did I say something equal to something else? Oh, my scanner next. Next line. There we go. Ugh. Next. I know your next line. Come on. Come on. You wanted the next line. Oh, yeah, that's right. There we are. Okay. Now that should work. Alright, so let's play. Alright, so we hit 23. Boom. It forgets. There's one dot, but not the other two dots. So, that's. And then it goes all the way back up to 23. And, of course, the Guardian protects it from looping forever. So, there we are. Okay. Now, next up. Yes, let's show what a break does. Now, the trick is on the break, you'll notice that we go 21, 22, 23. And then, so right here is where it should. No, it'll skip that. Okay, so if I say break is pretty much going to be like, well, let's just show it. Come on, break. And play. And let's go 24. Okay, so there. I forgot where I was. Eek. And then it just goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. So let's go show like break delabel, which functions like a continue, except because we're breaking here, it's going to include these two periods now. Oh, and yes, you did super duper. Okay. All right. 25. Now, there we go. There's the other two periods, and the 2, and then because it evaluates this time one more time, and then keeps going, keeps trucking. So yes, you're seeing the 3 dots here, but because of where I place this if statement and this break and how I'm breaking, this is for y'all to try out and enjoy. So I guess that's pretty much it. This is the main code for one of the world's worst counters, because this will get annoying if you choose a really high number. And I leave it at that, because this is a way for you to learn and play with break and continue, and with the various labels set up for one of the world's worst counters, because it actually does forget where it's at occasionally. So yes, there's that, and let's go into a thing here. Break is designed for use with the switch statement or loop structure in mind. The unlabeled form is naturally set to the innermost switch statement loop structure. It can be used with loops to skip past evaluation. A labeled break is usually used in conjunction with an if statement and an alteration of a switching value. So in a switch statement, if you for some reason want to change the value that was input into it and then break up in out of that current nested statement and keep evaluating for the switch statement above, yes, you can do that. And finally, the continue statement. Yes. Oh, go back to the pretty screen. Continue is used with labels for nested whiles, do while, and for statement loops for flow control. The unlabeled form is naturally set to the innermost loop. And a labeled continue is used to specify which loop of a nested set to target on the jump in flow control. So, continue, break, very powerful keywords, and their scope is only good for nested flow control statements. Break for both switch and loop, and continue for loops only. So there we go. And my name is Charles Anderson. I'm an indie game developer. My project is Idiog. I have an email. I have a Twitter. And it's really hard to see. I need to alter that. But we'll get that done. All right. Y'all have a good one. Thanks for tuning in.